Okay, here is example 2. We are talking today about subtracting rational expressions. And this one is a little bit more complicated than the one we started with. Okay, you're going to see that these two fractions do not have a common denominator. I know we see this x squared, but we can't really find a common denominator until we first factor both of these. Okay, so if you remember, this is actually a difference of two squares. There's a minus here. Perfect square, perfect square. So you absolutely can use box and diamond. Okay, if you think about this as x squared plus 0x minus 9, there's no middle term here, so you can put in a 0x. You can use your box and diamond to solve that if you'd like to, or you can remember what our shortcut is. Okay, and our shortcut would just be to factor it to become x minus 3 and x plus 3. Again, it only works if this is a minus in between. These signs are opposite. X times x makes x squared. 3 times negative 3 makes 9. And if you multiply out negative 3x and positive 3x combine like terms, that's where the 0 comes in. Okay, on this side, use your box and diamond. Okay, unless you're able to do that in your head, that's fine. We've got an x and an x combined to make x squared. This negative 15, I know 3 and 5 multiply to make 15. I have to add to make a positive 2, so it's a positive 5 and a negative 3. If you don't like that way of doing it, go ahead and use your box and diamond and just get the factoring correct. Okay, now, like yesterday, we're looking to make these two denominators equal. They already have one part that's equal, but then they have one part that's not equal. So we're basically looking to keep them the same. Okay, so when I do this next step, what's going to happen is I'm going to keep this x minus 3, which is actually in both. I'm going to keep the x plus 3, and I'm going to keep the x plus 5. This is what the common denominator is going to look like. So I have to turn this one, this denominator, into looking like this. I already have an x minus 3 and an x plus 3. What's missing is the x plus 5. Okay, and I don't have a lot of space here, but if I multiply the bottom times x plus 5, that's this one, I have to multiply the top times x plus 5. Okay, same thing on the right side. I already have an x minus 3 and an x plus 5. What's missing is the x plus 3 here. So I'm going to have to multiply this by x plus 3, and whatever I multiply on the bottom, I also multiply on the top. Okay, and again, that's because I'm allowed to multiply by 1. X plus 3 over x plus 3, or x plus 5 over x plus 5 really just makes a giant 1. I'm allowed to multiply pieces and parts by a giant 1. Okay, so I have my denominator down here. I've decided what I'm going to multiply there. Now, I can almost ignore these denominators. I've taken care of it. I have to pay attention to the top. And remember, the biggest thing with subtraction is I have to think of this as a negative 6. Sometimes I even put a plus sign here and just make that negative. That way I know I have to distribute the negative 6 to both of those parts on top. Okay? Over on the left side, I have to multiply the x through. So I'm going to get x squared plus 5x. Okay? Plus, now I have to distribute a negative 6x, and I get negative 18. Okay? So here I am. I have to combine like terms. These two things in the middle are definitely alike. So on top, I'm going to get x squared minus 1x minus 18. My denominator is just going to be exactly the same as over here. I'm going to try and squeeze it in. X minus 3, x plus 3, and x plus 5. Okay? I want to check and see if I can factor the top, but when I'm thinking about it, 18 has factors of 1 and 18, 2 and 9, 3 and 6. None of those get to a 1 when I subtract. So I can't factor the top anymore, which means I'm done. Okay? If I could factor the top, there'd be a possibility that I could make a giant 1 and cancel. In this case, I can't do it, so this is my final answer.